Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I'd kindly like to request our members to subscribe and engage us in the comment section and also ring that notification bell so that you can be getting various updates on our uploads on a similar topic. So in this case, we're going to look at the concept of the median, and this is going to be a general representation for the median of an grouped data. Now, from our first video, we had basically defined the concept of a median as a value of variable which is going to divide data into two equal parts. And we had given a general case for a representation of a median using this specific representation. Now, for group data, we had a specific general formula for representing this particular concept of an average referred to as the median. And for group data, I'm going to use that specific illustration which I've given for A and B in trying to find a general case for evaluating this particular average that we refer to as median. So therefore, we're going to have this particular formula which is going to be used in evaluating median for group data, whereby we are going to have this specific case being given for two cases for odd and even number of n. As we said, these are going to, of course, constitute the number of observations in this specific set of data. Now, in this case, if the value for n is odd or even, we're going to have two different ways of representing this specific concept for finding the median of these two respective numbers of n for odd and even are given as such. So for odd values of n, we're going to use this particular formula of x into x plus 1, and this is going to be divided, so this is going to be n plus 1, where n is the number of observations divided by 2, and this is going to be used for a value of n which is an odd value given as such. So we shall use this formula in finding the median. So for the case of values which are even, we're going to use the formula of half x n divided by 2, and then this is going to be x n, and then plus this is going to be n over 2 plus 1 given as such. So we're going to use this specific value. So we had said that basically we're going to have this particular numbers represented as I. Now this specific subscripts are going to represent the values of I in this particular case. So suppose we have a xi given in terms of distributions of these specific numbers of x2 to xn. Then these particular numbers for 1, 2, 3 are going to be represented using these specific notations which I've indicated. So suppose we have a specific range of data like the one that we have considered for A and B, which is ungrouped. We can identify whether this is an even or odd number of n observations given by counting this one. This is 1, 2, 3, 4, 5, 6. So the first one for A is having a value of n equivalent to 6, which is basically an even number. Of course, we're going to use the second formula for trying to evaluate its median. And of course, for the first, the second one for B, this is a 1, 2, 3, 4, 5, 6. Of course, let's try to it's a specific. So that is going to be. So I'm going to have a notation which I'm going to give for this particular second one. So for us to obtain the number of n for the second one, we're going to arrange this specific, irrespective of the number of appearance for this second one, we're going to arrange it in, of course, an ascending order by having it given us 1, 2, 3, 5, and 8. So these are going to give us 1, 2, 3, 4, 5. So the value of n is going to be 5 observations, whereby this one has been observed twice, but it's the same value given as 8. So therefore, we're going to have this one for even and odd, respectively, for these two distributions for A and B. So therefore, these are going to be appropriate for us in trying to use these basic formulas for finding the median of this set of data which I've given as such. So if we try to evaluate that one, then therefore for the value of n is equivalent to 6 for A, we shall have the median for A given in terms of, this is even, so given in terms of this median is equivalent to half the value of x. So we have said n is equivalent to 6. So we shall have 6 divided by 2 as a subscript for this specific value for x, plus x into 6 over 2. So this is going to be 6 over 2 plus 1. And then we shall have this one given as its median. So in further evaluating this, we shall have this one given as x3 plus x. This is a 3 plus 1, which is x4. Therefore, we're going to identify from our specific set of values and the number for x3 and x4, which are going to be representing a range of values in this particular case. But we said that for us to obtain the median from a specific set of data, we're going to arrange this one in an ascending order. So we shall have the first one being represented as 2, and then we have from 2 we have 4, 6, and then we have so there's a 5. We're going to have 6, 8, and 9, which are representing these values for A. So we're going to identify this one from x1, x2, x3, x4, x5, and x6. So our x3 is going to represent a value of 5, and x4 is going to represent a value of 6. So this implies that we're going to have the value of 5 plus 6, which is a half of 11, and therefore this is going to be a value of 5.5. So therefore, from the first set of data which we're going to have for A, our value for the median is going to be evaluated and found to be 5.5 using this lower formula, since our n is equivalent to 6, which is an even number given as such. So for B, we are going also to use the upper formula, which of course is going to be applicable for odd numbers of n, whereby we're going to have our median given in terms of x into n plus 1 all over 2. So which implies, of course, that we're going to have this particular set for x. So basically this is going to be representing a subscript. So I don't know whether I write it. So we're going to have this one given in terms of x into n plus 1 all over 2. And this is going to be given as such for odd numbers. So therefore we are going to do an evaluation for this and try to find out what basically this one is going to entail. So we're going to have this one as x. The number of n for the second case for B, as we said, is 5. So this is going to be 5 plus 1, of course, which is going to be divided by 2. So this is going to be basically x. 5 plus 1, this is going to be 6, divided by 2, this is going to be x3. So our value for the median for the first set of data, which constitute the second set of data, which constitute n, which is an odd number, is going to be x3. So we shall arrange our data in that ascending order, which I said, of course, representing the various observations, which of course we said, so the x3, this one being x1, x2, x3, x4, x5, this is going to be representing the value of A, which is basically going to form our median for that ungrouped set of data. So this is a specific procedure that we're going to use in evaluating the median for ungrouped data, using for this specific formula for the value of n, which is equivalent to odd, and the value of n, which is equivalent to even observations given as such. So check our description boxes for various links of other videos, and also engage us in the comment section and ring that notification bell to be getting updates on various links of videos that we upload in statistics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.